Today we're going to learn how to locate an earthquake. So first we have to understand that a seismograph produces a record of the waves. They record the displacement of the ground as a function of time in 3 directions, which makes a seismogram a record of the waves. Here I have one below. So on the x-axis we have time, on the y-axis we have ground displacement, and here we have the waves. So the first type of wave is the primary wave, or the P wave. P waves are compressional, and they change the volume of rocks. They're the first to arrive, and they have the highest velocity out of all the 3 waves here. Then you have S waves, or secondary waves. They change the shape of rocks, but not the volume. And these are both body waves. They occur in the interior of Earth. Then you have surface waves, which occur on the surface, and they have the highest amplitude out of all the waves here. Scientists then are going to use time travel graphs to locate an earthquake. They utilize the difference in P and S wave arrival times to determine the distance from the epicenter. Now, the epicenter is the point on Earth's surface above the focus where an earthquake is. The focus is the point where the earthquake originates from within the Earth, and it's going to be in the crust, below the crust, not directly on the Earth's surface. So the first step in this process is determining the P wave arrival time. So P wave arrival time. All right, the next step is going to be determine S wave arrival time. The third step is going to be calculating the difference between P wave and S wave arrival time. The fourth step is using the time travel graph to determine the distance of the station from the epicenter based on the difference between the P and S wave arrival time. So distance of station from epicenter The fifth step is we're trying to find the earthquake's focus, and it could be anywhere that is at a distance from the station. So to visualize the possible locations, they use a compass to draw a circle around the station. So you're going to have the station here and draw a circle around it like that. All right, these 5 steps result in a circle of seismic activity, but they do not pinpoint the epicenter. In order to pinpoint the epicenter, scientists use triangulation. So let's talk about that. Triangulation is the process of using 3 known points to determine an unknown location. Seismograms generated at 3 different locations allow scientists to pinpoint the earthquake epicenter. And the epicenter is the point where all 3 circles overlap. So here I'm going to give us an example. So we have our first little state, and our next one, and our next one. All right, and I'm going to grab a different color to represent the stations and a color to represent the circles. All right, so I'm going to use pink for the stations. So there's 1, there's 2, and there's 3. All right, now we're going to draw the circles. So here's our first one, here's our second one, here's our third one. All right. And so the epicenter is the point where all these overlap. So they overlap right here. Now in this case, we used 3 stations. However, in order to get more accurate results, if they're not that close to overlapping, you can use more points to ensure accuracy. And this is how scientists locate earthquakes.